This video is going to be an introduction to the tangent and cotangent graphs. A little different than the sine and cosine graphs, but some of the information and how we will do the transformation stuff will be the same with a different parent graph. So the first thing you want to do is take out your calculator, put it in degree mode, and I'm going to show you how to put this into a table ask feature. So we're going to put in our y equals, clear out whatever's there, put in tangent of x, and a couple things just to make sure that none of these are highlighted on top, and also scroll down and make sure that you don't have anything else that would mess up your graphing, because those could be issues you would have in your calculator that you might not realize, and then the table or the graph wouldn't work. I'm going to hit second window, and I'm going to switch. Currently yours probably says auto. Change it to ask for independent. Now when I hit second graph, I have information in here. I'm actually going to delete this out. If you don't have anything, you're good, but if you hit delete, so I'm going to delete a couple times and get everything out of there. I can now plug in the values that are in the tables. So I'll put in 85, 88, 89, 89.9, 89.99, and then 90. Before I even hit enter for 90, you should recognize from our first unit that tangent of 90 is undefined, so we will get an error message there. And I'm just going to go and record those numbers in, and we'll talk about what's happening. So 11.43, 28.64, 57.29, 572.96. You kind of see the decimal place moving over each time, and then we get undefined here. But if we kept getting closer and closer, so we're saying as x approaches 90 from the left side, because 85, 88, 89 are all numbers on the left of 90, y is getting bigger and bigger and bigger. So you have to think about what is that number? That's the biggest number out there. If we went on forever and ever, it's approaching positive infinity. So that's telling us something specific about what that undefined is going to mean for our graph. We're going to do the same thing for the other side. You can actually just overwrite these if you don't want to delete them out. So I'm going to go back to the top and just put in 95, enter, 92, enter. I don't know if I said this initially, but you do have to hit enter each time you put these different numbers in. And then we have the 90 again. So the difference here is we have the exact same numbers, but they are negative. So we're going a different direction here. And again, undefined. So as we're getting closer to 90 from the right, our numbers are getting larger but negative. So we're approaching negative infinity. Because either side is approaching infinity, we have to think about arrows. Rather than having a hole in the graph where it's undefined, we are going to have a vertical asymptote. So sine and cosine graphs were continuous. Our tangent and cotangent graphs will have vertical asymptotes now because we have these spots where the graph is undefined. Then we're going to go through and get some specific points in our table. You can use your unit circle for this, or your knowledge of the unit circle. So tangent of negative pi is 0. Tangent of negative 3 pi over 4 is negative 1. Negative pi over 2 is your undefined. Again, that's where we're going to have a vertical asymptote. Tangent of negative pi over 4 is negative 1. Tangent of 0 is 0. And then the only difference here, oh, you know what? I put negative 3 pi over 4 as negative 1, and it should be positive 1. Let me fix that, sorry. Tangent pi over 4 is 1. Again, the Pi over 2 is undefined. That's again a vertical asymptote. 3 pi over 4 is negative 1, positive 3 pi over 4. Negative 3 pi over 4 is in the third quadrant technically, so that would be positive for tangent. And then pi is 0. So if we graph that information, and I'm going to put the points on, so negative pi. Now on this axis, I am simplifying everything. You know, we had talked about not having to simplify when you're writing this stuff out, but I think it helps us to see the key points on here, so I'm definitely going to do it. And then do this. And on the other side, same thing. I'm purposely putting this in black, and like this would keep going this way. Down here. Now in blue, I'm going to put the cycle that we are going to be translating, because this is the cycle, the one cycle that will keep repeating. And our cycle is occurring between the two asymptotes. Again, I'm just getting the points from up above in the table. So just down below, underneath the range space, I'm just going to put a star. The blue is the original cycle. We will transform. Same way that we did sine and cosine, but there's some slight differences because of the fact that it's not continuous. We have different critical points. We now have asymptotes, a different period. The actual transformation stuff is going to be the same, but that information is going to be a little different. So our critical points, I'm going to label off the graph A, B, C. It would be negative pi over 4, negative 1, 0, 0, and pi over 4, 1. Now our period's different. If you look between the asymptotes, our period is going to be a distance of, in this case, 4 pi over 4, which would be pi. And in fact, when we go to do our transformations, it will be pi over b. Again, a little different. Our vertical asymptotes, I'm going to do the visible ones here from our graph. There are infinite vertical asymptotes, so we have to also think about a general equation for this. We have negative pi over 2 and pi over 2. So when I ask for asymptotes for graphing later on, you're going to give the visible ones on the one cycle that you're graphing. I don't have enough space for this here. I'm just going to say in general, your asymptotes are going to be, and you can really pick any. I usually stick with the positive one of your asymptotes plus the space between, in this case is the period, times k. And then you would say where k is any integer. And I have not a lot of space here, so I'm going to put that in when we go to do domain in a minute. This symmetry is odd. I can't really show this in a video, but if you put your pencil on your origin, it does go through the origin, and if you rotate this 180 degrees, the graph will look the same. Amplitude, we don't have any because we don't have a max and min point, so that's also different. In our domain, we're going to do all real numbers. Instead of doing negative infinity to infinity now, that's another option for that. It's all reals, and we're going to subtract off the set where x is equal to our vertical asymptotes, because every time we get a vertical asymptote, we have a break in the graph. We just want to write where k is any integer, because remember, it needs to be an integer for these formulas to work. And then these guys right here are your asymptotes. So at the asymptotes, we don't have a part of the graph. That's a space in our domain. The range for this graph is always negative infinity to infinity, so I never really asked you for domain for the sine and cosine graphs because that was negative infinity to infinity. Now we're going to be looking more at the domain because that will change depending on what the asymptotes are. We're going to take a break and do a second video for the cotangent. But again, just an intro video. We will be doing the graphing aspect together in class.